So okay, and then this is the compound. So before you go further with this session, please watch this video. Please watch this video, and you will gain more knowledge about this. So a compound DC motor is a motor with both a shunt and a series field. So it's a combination. Okay, the current flow into a dotted end of the coil. Shunt or series produce a positive MMF. So I believe you know already the magnetomotive force, the MMF. So please watch again. Please refer again to the previous slides. Okay, so for the long shunt, for example here, they are parallel to everything. For example, this is the winding. Okay, the field winding, they will parallel with everything, with the series and also armature. Okay, different with the short shunt connection. So the series, they just parallel with armature and parallel with armature winding and also the armature, and then series with the RF. Okay, if you can see here, there is a dot here. They have two dots here, where it is cumulative compound and differentially compounded. Okay, so we have two types of compounded DC motor. So actually, is the just a direction of the flux. Okay, so for example, if the current flow into the dotted end of both coil, so the rising MMF added produce a larger total MMF. For example, over here, over here, the winding, this one goes into, and this one come out. Okay, it's okay. Later on, I will show you the details. Okay, for the differential, if current flow into the dotted end of the coil and out of the dotted end of the another coil, the resulting MMF subtracted. Okay, this is the differential compound. Don't worry, I prepare already the slide to explain more. Okay, for the compounded DC motor shunt plus series, so this is the circuit diagram. Same goes to the this one. We just ignore it or assume it as 0. Okay, so just have the resistor, voltage, current. Okay, and then this is the supply voltage, and the supply voltage will supply the current, the total current IL. So the total current IL will separate into two, which is the IA and IF. So the total current equal to IA plus IF, and then the VT. So VT here is equal to this because it's parallel. Okay, IF, this one we just assume is 0. Okay, IF plus VT equal to IF times with RF. Okay, for this actually we this one also parallel, so VT is equal to IA. Okay, IA, not the IL, so IA times RS plus RA. So since series, so they can add together, so plus the EA. Okay, don't worry about the cumulative and compounded differential, we'll explain later. Okay, this is what happened actually, the flux direction. Actually, when we change the current flow, we change the coil direction. Okay, for example, the current flow is from here. Okay, current flow is from here, go into here. Current flow from here, so current flow from here, and then like this. Okay, like this. Okay, come like this. Okay, so this is the current flow. So for example, for here, current flow same from here. So but this time a bit different. They will go from here, something like this. Okay, the different coil restructure. Okay, so it will make the flux direction differently. Okay, change the opposite direction. Okay, they change the looping, coil looping, cause the flux change direction. So therefore, when we change here, so for example, when for the cumulative, this is the cumulative. For the cumulative, this coil and this coil will flow at the same direction. Okay, will flow at the, for example here. Okay, will flow at the same direction. So for the cumulative, okay, cumulative. Okay, so for the differential, for this one, for the shunt connection, they will change the current, change the flow. Okay, so they will move in the different direction. Okay, so when they move different direction, something will happen. For example, which one of the coil have the less resistance, so the current will flow there. Okay, so the explanation will be in this video. Okay, you will see everything in this video. Okay, therefore for the cumulative, this one is for long shunt. Okay, the flux will be added. For differential, for the differential compound, the flux will be minus. So the positive and negative sign indicate that the direction of the flux produced in the field winding. Okay, so you can see, you can go to this link to see more detail. Okay, for the short shunt, okay, so the direction of the current, we go first for the circuit. So this is the supply voltage. Okay, this is the RS, this is the shunt, the series field, and this is the winding, the field winding. Okay, and then this is the armature winding. Okay, when we do the current voltage law, so we will get for this one, we will get this. Okay, so when Vt equal to IL times Rs, If times plus If times Rf. Okay, so you need to see the properly the current. This is not the this is the IL for this, and this one is If. Okay, not IL. Okay, because it's already divided. Okay, okay, when we do the current KVL over here, okay, then we will get this point. So this equation, so Vt equal to IL times Rs plus Ia times Ra plus the back EMF. Okay, so for the cumulative compounded and differently compounded will be the same as before, as I explained before. So this one also the same, will be the same. For the compounded DC motor, the speed control technique same as the shunt motor. So what we need is actually change the field resistance. Okay, okay, we need to change this field resistance, either want to increase or to decrease. Okay, it's dependent on the situation. Okay, and also the change of armature voltage. So this is the armature voltage. So to change the armature voltage, more probably change the resistance over there, or maybe the current. Okay, for the application of DC motor, we see the wind field. So we have a shunt connected. So for shunt connected, the application is for the industrial application, grinding machine, so machine tool, okay, and so forth and so on. For the series, so series one, we need actually the high torque at low speed, so dangerous if not loaded. So drill universal used for the single phase is high power weight ratio. So for compound connected, can be designed to a tailor torque speed characteristic traction motor. Okay, for example, the if I'm not mistaken, train. Okay, so for permanent magnet, so as we know, this is familiar to us, the servo application, machine tool, computer peripherals, and so on. Okay, this is a picture of someone who maintain the DC motor. So up to here, so this is the end of the part 2, so we will continue to the part 3 after this. Thank you. So please study and good luck.